Hey, welcome to the fun probability problem solving sections. And today we are going to work a problem very similar like the one we worked in the other videos here. So this one is here tell us X is a discrete random variable with the following PMFs here. Okay, so I want to find the probability X greater than equal to 2. So for this problem here, we notice there is a constant C there. So in order to find X greater than equal to 2, we probably need to find the C first, and then we can take a look at what is this PMF looks like. Okay, so now let's go ahead to go to the whiteboard and see how we're going to solve these problems here. Okay, so we know the PMF here. Okay, so we know the PMF here is equal to 12 minus X over 6C. And X is discrete, so X can go from 1, 2, 3, and all the way to what? All the way to C here, right? So like we mentioned a while ago, we know we have a constant here, C, and have a constant here, C. So in order to find the probability X greater than equal to 9, we probably need to solve this C first. So let's see, because if this is the PMF, right, that means in here, just like if it's a continuous random variable, you integrate over the whole domain will be equal to 1. So here is the same thing. If you add all this number, x from 1 to 6 here, so if you add this PMF here, so this is 12 minus x to the 6c. So when you add them up, it has to be equal to 1. Okay, so let's see how do we add them up. So this is 6c, I can move the 6c to the front. It's 1/2. And so the inside, I have x equal to 1 to the c, then this is 12 minus x. So for here, I can break it to like two summation signs, right? So this is x equal to 1 to the c, the 12 minus, and the x equal to 1 to the c to the x here. So for this ones here, we know this is 1 over 6c. So what is this one? That means you add 12c times. So this one is 12 times c, so it's 12c. So the next ones here, we're going to use the property we know from the algebra. So we know when the n equal to like when the, okay, so when the I, okay, so like we said, when the I from 1 to n, so here's the I, that means if you have 1 plus 2 plus 3, da da da, plus to the n, this one we know, this formulas here will be 2, the n plus 1. Okay, so for here, x is from 1 to c. So what is these numbers here? This number will be the 2 all the way to c times c plus 1, right? Okay, so now let's try to simplify this. So this is 1 over 6c, and this is 12c minus 2c squared plus c here. All right, so now this is 1 over 6c, and find the common denominator, so it's 2. So this is 24c minus c squared minus c. So inside here, this will be 6c, and then here times, so how many c's here? 23c minus c squared. And so the same one, this is 6c, and times 2, I can take the c out. So this is 23 minus c, right? So then here I see, oh, okay, c and c cancel. And we know when you add the whole thing up, because this is PMF, has to equal to what? Has equal to 1, right? So then that's why we say the 23 minus C has to be equal to 12. So what is C here? C is equal to 11. Okay, so that means this is the x1, 2, 3, 4 tier C is here. Okay, now we have a probability. We need to find it's greater than or equal to 9. So that means it's a probability x equal to 9 plus probability x equal to 10 plus probability x equal to what? X equal to 11. And we will stop here, right? Because we know the C is 11. So the value of x is 1, 2, 3 to 11. Okay, so now x equal to 9. So C is equal to 11. So it's 66. 12 minus 9 is 3. And equal to 10 is 6 over 2 plus 66 over 1. So I have 6 over 6. So what do I have here? It's 1 over 11, right? So this is 1 over 11. So that will be the probability for the probability x greater than or equal to C. Like I mentioned, this is one very similar like the one we have in this series is like it's a continuous PDF with 2 variables. So that's why you need to have 2 conditions to solve it. So in here, we only have a C's here. So I will use it when you sum the PMF will be 1 to solve the C, and then we'll be solving the problem easily. All right, that's it. I hope you enjoyed this easy solving problems here. Talk to you in our next ones here. Bye-bye.